Okay, so moving on to testing a valve. I've got a quad of Phillips 12AX7 tubes of valves, whatever you want to call them. They're from about 1975, 76. I took them out of a twin reverb that I still have, and they basically have been sitting in the cupboard, not doing much at all. So we'll test this one and see how it's going. So we've got the machine turned on. We've set the selectors for the valve. We've set the dials for the proper filament voltage, negative grid volts, anode volts, and we're on triode 1 or anode 1. We've got the emitter selected to 100, so we're reading the full scale. The voltage, we'll just set that to about there. And we're ready. We got the set 0 fully clockwise. And we've got that on check cold. And so we're ready to go. So we'll slip the valve in. The valve's not on, so there's no glow on it, because the first thing we do is check to see that all the bits and pieces inside the valve, when cold, are not shorting, right? So we look at the meter and we check the heater first. So there's a short there, right? And that's because it must be shorted for the heater to work, right? If that needle swung back to 0, means that the heater is broken. So this case is okay. We go and check the cathode. No shorts. The grid, no shorts. Anode 1, plate 2, all good. Okay, so now we can turn the valve on. And to do that, we move this dial to the check hot. So we look at the valve while we're doing this. Fireworks. So the filament is nicely heating up. So this is probably more than 50-year-old, this valve, because it was taken out of the amp back then, so it'd been there for a while. And let's see how we go. Okay, so we're checking anode 1. Checking hot, all good. We don't have to go for this because we've already done that. So we check the cathode and heater insulation, just in case the filament has expanded a little bit and maybe touching bits that we don't want it to touch. No problem there. And so we're ready to test anode 1. So let's go ahead and do that. Right, so what can we see? Not much, because the scale, we've set that to 100, and so that's reading in the 100 milliamp scale. That's reading about 1 milliamp. So we need a bit more definition to see what the actual reading is. So we move that to 25. Let's jump a bit. And so now we're reading it in this scale. So that's reading a little bit over 1 milliamp. Still heating up. Okay, so we go on to the next scale. That's the 10, right? We went to there. And we're reading 1.2 because that now reads 10, 9, 8, 7, 6, whatever. And then we go, it's 1.2, right? We can go a little bit further and go to the 2.5 scale because the expected value is 1.2. So we're safe there. So that's reading 1.25. 2.5, 2, 1.5, 1.25. So as far as current draw goes, this triode's good. Okay, so let's move that back to there. And let's try NO2. About 1 milliamp, 1 milliamp, 1.2, 1.2. That's right on book value, which should be 1.2 milliamps current draw. So the two triodes are still pretty well matched. So I don't know why I replaced them back then, but these valves are working pretty well. So what we can do now is take that back. So we expect, we'll test the transconductance now, and we'll go back to anode 1, the triode 1, and we'll test the transconductance. Now the expected value is 1.6, and we're on the 2.5 scale, so just in case, we're just going to move that back to 10, to the 10 milliamp scale, just in case we get some odd transconductance that is too far out of the scale. So what we have to do now is we have to move the set 0 or the backing off control to 0. It's a little bit touchy. Okay. And now we press this button here, the milliamps per volt, and we'll get the transconduct value of the valve, the transconductance value. And that is reading 2.4. Well, the book value is 1.6. 1.6. And we're getting 2.2 on triode 1. And go to triode 2. The meter's moved a little bit. Okay, that's good. Press the button. What do we get? Sorry, that's 2.4, right? 2.4. So that's a pretty good valve after all these years. So we've basically finished testing the valve. And from this we can see that both triodes are pretty well balanced. The next thing we can do is to test the overall quality of the valve. Well, we already know that the valve's pretty good, but we can go one step further and check the quality of the valve by going on to the red and green scale. We'll adjust the backing off a little bit more. Bit touchy, that there. Okay, so we were expecting 1.6. That's where this dial comes into play. We were expecting 1.6, but we already know that for anode 1, we got 2.4, didn't we? Just reset that. Yeah. Touchy. About there. So we're expecting 1.6, but we already know that we got 2.4 from the previous test. So let's just have a look what we're going to get now. Super good. It's almost off scale. Almost off the green scale. So what we can do, we can set this to, what do we get, 2.4. Set that about there. Press the button again. Well, the valve is good, right? That triode, no problem there. Triode 2 should be pretty much the same. Adjust the backing off a little bit. And we'll try that again. Good. That's pretty good. So, okay, what's the result? The result is that we've got a good valve. So the current draw is good. Transconductance is good. And that's all we need to know. Okay, so having done that, we can reset the instrument back to testing conditions. So we turn the backing off of the set 0 dial fully clockwise. We make sure that, okay, anode 1, and we can now go back while the valve is still hot, and we can test noise in the valve, okay? Because the valve is now fully heated up. If we turn the knob, the circuit selector, anti-clockwise, if the needle jumps now, there'll be an indication that there'll be maybe a noisy valve happening when the valve is working. But that's fine. That's fine. So we can turn the valve off. And the mains voltage is still good. So we've done testing the 12AX7. Next, we'll try and test a rectifier and a 6L6. We'll see you then. Turn the machine off.